Hello everybody, so today I am here and I'm going to evaluate this limit over here using the infamous L'Hopital's rule. So L'Hopital's rule was a rule made by the famous French mathematician Guillaume de L'Hopital. And so today we have this limit over here, the limit as x approaches infinity of 4x cubed plus 3x cubed plus 2x cubed all over x cubed. So we're gonna go ahead and evaluate this using the infamous L'Hopital's rule. So first of all, if we only plug infinity, obviously what we're gonna get here is infinity over infinity, and something like this, or also 0 over 0, is in the indeterminate. Hold on. I spell this really badly. I'm sorry. I say it really badly. Indeterminate form. Indeterminate form. And so when you have this, what you can do is use the famous L'Hopital's rule. So some people write it with an S over here, and that's also correct, but the pronunciation is L'Hopital. So this is the correct pronunciation. So we're gonna go ahead and start. So first of all, we don't use the quotient rule. So let me basically explain how to evaluate using L'Hopital's rule. So you're gonna take the derivative, and based on that, you're gonna be able to evaluate it. So you don't use the quotient rule. You're gonna do a numerator and denominator separately. We're not gonna do them all together. So this is what you do in L'Hopital's rule. So in this case, as we can see, we have exponents. So we're gonna use the famous power rule. So you should know this already. It's used in derivatives, obviously. So we're gonna go ahead and start. So first of all, we have 4x cubed. Hold on, let me first write, this is important, always write this. The limit as x approaches infinity. 4x cubed, when we derive that, we're gonna be able to get 12x squared plus 3x cubed, 9x squared plus 2x cubed, 6x squared. All over 3x squared. Sorry if here you can't see the too well, this marker is really thick. So this is using L'Hopital's rule. So again, we see here, if we plug in the infinity, it's still, gonna be infinity over infinity. So we're gonna keep going on with L'Hopital's rule. The limit as x approaches infinity. So we're gonna use the power rule again. So we get 24x for 12x squared plus 18x for 9x squared plus 12x for 6x squared. All over 6x for 3x squared. So again, this is still not done. We're still gonna need to use L'Hopital's rule. So when you want to use L'Hopital's rule, don't forget to write LHR. Also, by the way, guys, in some questions, in some tests, for example, on the AP calculus test, they're gonna ask you specifically not to use L'Hopital's rule because it just makes limits so much easier. So for that, you'd have to use the regular way. You can use quadratics. You can simply plug in if it works. It doesn't in the AP test often. But yeah, L'Hopital's rule sometimes is prohibited in some tests. However, sometimes you are allowed to use it. So now we're gonna go on. We're still not done, so we're still gonna use L'Hopital's rule. The limit as x approaches infinity, 24x is simply gonna become 24. Plus 18x simply going to become 18, plus 12 simply being 12x simply going to become 12, all over 6x becoming 6. So over here we see we don't have x anymore, so if we simply do the math, we won't get infinity over infinity or an indeterminate form. So we're going to go ahead and see that. So 24 plus 18 plus 12, I'm pretty sure this is 54 over 6. So hold on, let me just make sure that this is actually 54. 24. 54 over 6 is 9. Let me make this, sure. Yep, it is 9. And so this is our answer. We have evaluated this limit using L'Hopital's rule. I hope you guys enjoyed this video. If you have any more questions on this, don't hesitate to comment or to email me. The email is in the description down below. If you want me to make videos on specific math questions or topics that you wish to. Don't hesitate to comment or to email me. Don't forget to like, share, and subscribe. And I hope to see you guys soon for another video.